Good morning. Welcome to another sunny day in the shop. Time to make some pulleys. So here I've got a big chunk of 3/4 inch plate. I'm going to punch out some blanks with a hole saw here. As you can see, this is not the first time this plate has been used for that purpose. So I'll cut those blanks out and then take them over to the lathe. And here I will knock out the inside diameters to match the bearings. That's 22 millimeters to match the 608 bearing. And then I just finished making myself a little mandrel here. Got that set up in the 4-jaw, all dialed in. I'll pop the blanks onto there, and that'll let me turn the outside features of the pulley. All right, let's get to work. All right, I got my pulleys made. Got me some bearings here. And so these things are a little bit wider than two bearings stacked up together. So my plan is to use a few washers here to make up the rest of the difference in height. And that works out, 3 washers, works out just about perfect there. So I will press that in between here. So I think that's going to work all right. Let's give her a shot here. All right, working away here. Got my pulleys all made down in there. Everything's working, and I got the little shaft extensions for the stepper motors worked out there. That's fitting all right. So everything's doing good. Took a little bit of work to get everything to align nicely. Why is that? Oh, that's why. The wires are touching. I was wondering why that wasn't spinning very well. That's much better there. If you cross the right wires here, it kind of locks up the motor, so it doesn't want to spin. And these were touching the metal frame, so that's what was happening there. That feels much better. Yeah, so it took a little bit of work to get everything lined up, and I had to remelt the holes a little bit with my little grinder down there. But it is looking great. Oh yeah, and I also made some belt tensioners here. So these are them. I just got to lay on my back and drill those up into here. Or I got a hoist up there. Why don't I use that? That seems a whole lot better than laying on my back. I'll just flip this thing up on its side. So yeah, making good progress. Okay, resuming work in the morning here. Ran out of time and energy last night. So I got the belt tensioner that I'm working on here. Just got to drill a couple holes up in there for some locking screws to lock the tensioner in place once it's tensioned. All right, let's get that done. All right, resuming work after the weekend here. Just got the belts tensioned. I did that with the what do you call it? The frequency analyzer method, which was a little bit tricky. A few things. This is not a guitar string, it's just a rubber belt. So it doesn't vibrate very nicely, especially at low tension. But I managed to get it pretty darn close. Everything's within like 1 hertz as best as I could figure out. Of course, great care needs to be taken in making sure that this side is at the same position as that side, because if you're shifted a little bit, obviously the frequency is going to be a little higher on this side than that side, and that'll throw things off. So I just leveled down from here to the cross member on both sides to make sure that I was even there. And that seemed to work. So tension is a bit of a important part here, because this is just a piece of rubber. It's not steel like a screw or a one of those what do you call them, like rack and gear systems. This will stretch. So if you stretch it tighter, that makes it, which is it here now, that would mean that there is actually less teeth per inch. The spacing would be greater because it's being stretched out, which means that the stepper motor is going to have a different amount of travel per turn from one side to the other if you have different tensions in your belts. So really what you want is the same amount of teeth in the belt from one end all the way down to the other. And that's what the tension or the frequency tuning sort of thing attempts to do, in lieu of getting down there and counting each one of these teeth and making sure that it lines up from one end to the other with a physical measurement. And so that affects a couple of things. It's going to affect squareness, because you can get this set up at one end of the machine and have everything perfectly square. But when you move the gantry down to the other end here, over 8 feet away, if those belts aren't exactly equal from one side to the other, you're going to be out of square at this end. So what is square at one side might not be square at the other end. So I've got a plan though, so I'm not too worried about this belt tension thing at the moment. For squaring things up and calibrating everything, I think what I'm going to do is get one of those cheap DROs, like a single axis DRO with a 2-foot or 3-foot magnetic scale. And instead of using JD's Garage's method, which just uses a simple 1-inch dial indicator, 1 inch is great. You can get it pretty accurate, but that's only over 1 inch. If you expand like one, say you're out by 2/1000ths over 1 inch, that can compound, of course, and you'll be out significantly at the other end. So I'm with that glass scale, if I can reduce that error down to, a couple thou over 3 feet, that's a whole lot different once you get down to the other end. So that's my plan for calibrating things when the time comes. So the other thing that's been keeping me awake at night is this Z-axis. It's working okay, like things slide pretty nice until you get right to the top. There we go, it's holding. It doesn't take much, and she drops, and same thing with the x-axis. Ow. Pinched myself there. The x-axis, once you get down to the bottom, it binds up a bit. Slides a lot better in the middle, but still not great. So what's going on here is when I had the bottom off, I could see that as I was messing around with things and sliding this up and down on the rails, with one end of the rail still fixed in here, you could see that the rods were moving in and out. And when you you move this all the way to this end, this was splaying out those rods, meaning that my spacing is obviously different. And this is, these things are slightly wider than the spacing of these holes, the clamp holes there and there. So when I built these components, the plates, the top and bottom with the clamps here, that was, let's say, like an absolute measurement. I had this set in the machine, and I pulled a measurement off of center each way, exactly the same in one fixturing. Same thing at the bottom with this one. So there's an absolute distance between one to the other, a fixed distance there. As you may recall, when I built these components, I was in production mode, and because they were all the same and symmetrical side to side, I had a stop set up in the vise, and I drilled one hole, and then I flipped it around and drilled the other hole, and I did that for all three pieces. And if I had these things exactly the right length, and if everything was perfect, it should have put those in exactly the right spot. And I haven't gone and measured this to see exactly where things are out, but I suspect maybe I didn't quite get down to exactly 4 inches or something with that. So these holes ended up being actually a distance between this face and center line of hole, and then from this face to center line of hole. So there's not an actual, like I never took a physical measurement from there to there. It was indexed off this end to here, and likewise. So if that distance is out, obviously that's going to change the spacing, and I think that's what happened. So what do? I can remake these parts here. I can try and re-drill out these holes a little bit and hope for enough slop in the bearing flanges here that I could maybe shuffle that over. That's a fair bit of work. I would have to recut that shoulder each side there times 6, and same with these bores here. I'd have to re-index my boring head and try and pick up that hole again and move them over. Or I do the opposite and I make the bottom and top plates match whatever this distance here ends up being on these things, which is, I think, the route I'm going to go. So remaking those 2 plates, not too big a deal. There is a fair bit of work in those, especially with, all this stuff up here. So before I go that far, I'm going to try one thing. I'm going to try and salvage it by welding up the hole that clamps the rod, maybe just on one side. And I'll weld it up and then pick up this hole and then take a measurement straight across and measure this and make it match whatever I'm measuring here. So I'll try and salvage the part by doing that. And if that doesn't work, then I'll just cut some more pieces and remachine those to make new ones. And then I will sleep better at night. And this thing will probably work a little better too. So, all right, so that's going to be the plan. So let's start tearing things apart, take some measurements, and get to work here. All right, so I just pulled things apart and confirmed exactly what I thought it was here. These blocks ended up being that I left about 5 thou extra on the width here. It's not much, it's pretty close, but it's definitely off a little. So that throws off this measurement, and it's literally only 5/1000ths of an inch when I check my spacing in between here to here. These ones actually ended up being really, really accurate, as I suspected, because I just had it set up in one fixturing in the mill and used the DRO, and it worked out great. These ones I was indexing off the end, and because of that extra 5/1000ths, this is a little extra wide, and that's what's causing the binding. So I am going to redo these things to make them match this. So I just got to move that hole over 5/1000ths of an inch. 5/1000ths of an inch, like it's that little, and it's making a bit of a difference. So I will get that fixed up here shortly. And I also noticed that in the process of taking this apart and messing around with things and whatnot, I think I got some grit into these bearings here. So I've ordered a new set of those, and I'll replace those as well so that things slide better on there as well. So that's the plan. Let's pop this apart here, clean it up, and see if we can throw some weld in there. So I got my parts welded up. It didn't turn out too bad, but I couldn't reliably pick up on this hole confidently enough, like within 5/1000ths, because I got a little bit of run out in my chuck, and I wasn't getting a good pickup on that. So I decided to make a new part, which is this right here. And I'm on my last operation here, and I went and I bumped my power feed and fed the thing into the bit and wrecked my part. So now I got to make a new part, or actually I'm just thinking I can probably weld that and recover and reclaim that there. Okay, I gotta go do that. Oh, this sucks. I don't want to have to make this thing a third time. All right, finally got it all back together. Everything is working very nicely now. There is absolutely no binding whatsoever in there. In fact, I can move this by hand, even with the motor hooked up here. I got the new, not ball screw, lead screw nut that's on there. And everything spins and moves very nicely now. I've got my limit switches on. Got those mounted. Had to recess that one a little bit to clear everything. Down at the bottom inside there I got the little limit switch for, that's my touch off switch there for that one. So that will be very, very nice. So let's get that all back together. So next step is going to be to do this belt here. I got to make my mounts and get those mounted on. I also remembered I want to stiffen up this. As you remember, I said I wanted a little bit of flex this way, but when I bump it like this, there is like, you can see like a little bit of vibration. So I'm pretty sure that's going to translate into the smoothness of the plasma cut. So I had originally planned that I'd be doing some gusseting in and around this whole thing here to stiffen it up in that direction. So I got to do that yet too, but I think I'll do that like right when I disassemble it to paint everything here. No sense of pulling everything all apart right now. I want to get this belt on and get some wires run and see this thing actually move. We're getting close. We're getting close. So anyway, let's get to work. All right, so I just got this mounted here, made my little brackets and mounted the belt. Everything slides nice now. So next step here, I'm moving on to the limit switches, or homing switches, I should say. So I'll mount one right here, somewhere around there, right where that hits the end, and that'll hit that little tab that I just welded on there. So I just got to position that. So there's one there and one at each end here of the y-axes. So those ones need to be adjustable, of course. So I'll need to have like a little bolt or something that screws out so that I can use it to square up my gantry there. And the ones on the z-axis here, I just located those pretty precisely because it's just a little bit away from a hard stop there. So I wanted those to hit that. And same thing for the touch-off switch down there. So yeah, all good. Let's get to work and get those installed. All right, got the limit switches on. They go click, click when they're supposed to. That's great. I've got these little screws in here which I can use to adjust. Of course, I'll need some lock nuts on there as well. Drill the hole to run this through the tube. That'll keep things protected. Of course, there'll be some protective casing on those. The sheath, I'll bring that through and, I don't know, drop it out somewhere around there, which I think is where the electrical cabinet is going to go. Speaking of which, I got that over here. That's the next step. So I will pull this backplane out and start drilling and laying out my components. I did a bit of a layout on Fusion to give me a good idea how I want things all to go in there. That thing's dirty in there. I'll have to clean that out. Yeah, so let's get to work on that.